Hello everyone, this is Hasib, graduate student, Department of Physics, Western Illinois University. Here I am presenting our group research work, Compositional Dependence of Density and Refractive Index in Bismuth Boro-Tellurite Glasses Co-doped with Prysodium and Dysprosium ions. Here with me, my co-author A.K. Ashkur Rahman and my mentors, Dr. P.K. Babu and Dr. Malur. So now we can start whole thing part by part so that we can understand it quite deeply and very slowly. So as we have noticed that the main glass is Bismuth Boro-Tellurite glass. So why we use this one? In short, we can say that we use this one because it's an ideal host material for rare earth ion that shows very good chemical stability over wide range. On the other hand, rare earth ion doped glasses are very interesting in applications like solid state lasers, optical telecommunications, electro-optic device, and photovoltaics. So in this study, we will investigate the variation of density and refractive index with base glass composition. Now the fun part, our sample preparation and methodology. In this time, I have divided these steps with two main objects like sample preparation and methodology. In sample preparation, we use basically two major equations. Here it is. We use 10% tellurium oxide and 20% tellurium oxide. And in these equations, we calibrate our base material bismuth oxide from 30 to 50 mole content. For preparing the samples, first we collect our compositions, then we make the measurements with balance machines and mixing them very well. Then we kept it in the furnace around 10 to 15 minutes with 900 Fahrenheit temperature. Then we quickly perform the quenching, then kept it for annealing to reduce the internal thermal stress. And finally, we polish our samples and smooth it. So this is our experimental part on the left side. For analyzing the samples, we use two methods. For density measurement, we use Archimedes principle. For refractive index, we use Brewster's angle method. So what is Archimedes method? So it's a common method for finding the density of a substance. So our substance is our glasses. So this principle actually states the bound force of an immersed object by a liquid is equal to the weight of liquid that is displaced. So our immersed object is definitely the glasses. So in short and summary, we can say that if the object is entirely immersed, then the volume of the displaced liquid is just the volume of the object. So we use these equations for measuring our density. So the method is very simple. We took measurement in the air of our glasses and we took measurement our glasses in the liquid, and in this time we use liquid as xylene. On the other hand, for refractive index, we use Brewster's angle method, and the Brewster's angle method is actually the angle of incidence where light will be perfectly transmitted through a surface with no reflections. So all transmitted light will be P fluorescent light. In this figure, we can explain this one. If we took a light source, we can see that here all transmitters are P fluorescent light and no reflection light with P fluorescent. This is the actually Brewster's angle method. So after calculating the refractive Brewster's angle method, we just insert in these equations and calculate our refractive index. After doing this analysis, now we got our desired value, the density. So in the table 1, we can see that there is two parts. One is for 10% tellurium oxide and another is 20% tellurium oxide. In 10% tellurium oxide, we can see that we calibrated our bismuth oxide content 30 to 50%, and the density is actually increasing. So if we plot the value in a graphical representation, in the left blue graph, this one, you can see that the density is increasing with respect to mole content. On the other hand, if we consider 20% tellurium oxide, we can see that the graph is not uniform. The reason behind of this, actually their presence of heavier ion of tellurium and bismuth oxide. That's why it's become pretty much weird. So if we analyze that, we have increased our tellurium oxide almost double. That's why this double impact on the results. Similarly, for refractive index measurement, first we have to calculate the Brewster's angle. This is actually a symbolic graph for measuring the Brewster's angle. We can see that when the intensity is lowest, we can call it Brewster's angle actually. So in this picture, we can see that the Brewster's angle is 66. So we insert this 66 value in our equations and we got our refractive index. So after getting refractive index, we can see that there is also two parts, one for 10% tellurium oxide and another for 20% tellurium oxide. For 10% tellurium oxide, refractive index is actually increasing as 10 tellurium oxide for density. But for 20% tellurium oxide, we can see that it's not uniform. It first increase, then again decrease. So the similarity of tellurium oxide with density and refractive index analysis, we can see that when density is lowest, our refractive index is highest. And refractive index shows this characteristics because of presence the heavier polarization ion of tellurium and bismuth oxide. So finally, we can conclude that for 10% tellurium glasses, density increases from 5.662 to 6.815 gram per cubic centimeter with the variation of bismuth content, and for 20% glasses, density variation is not uniform. The reason behind of this is the presence of heavier ion of bismuth and tellurium. Similarly, for refractive index, it's increased from 2.071 to 2.148 for 10% mole content, and for 20% mole content, again it's not uniform with respect to bismuth oxide content. And the reason behind of this is the presence of highly polarizable bismuth and tellurium ions. Now we may be curious what we will do the samples in future. So we can use these samples for analyze like optical band gap and fluorescence. So I am to thank our nanomaterial research group, Department of Physics, Western Illinois University, and our former student Arifur Rahman, who helped us preparing samples in the last semesters. So that's it. Thank you everyone for your time. If you have any questions, please feel free to comments. I will glad to answer you and respond. Thank you. Bye.